Here's our cash register class. We've removed the examples in order to fit more of this on the screen at once. We have our special method _init. As you know now, this gets called when you create a new cash register object. We also have regular methods getTotal, add, and remove. We're going to add another special method, _eq, that will be called when we compare two cash registers for equality. For this method, we'll consider two cash registers to be equal if they have the same total amount of money. Our method has self as the first parameter, as per usual, and the second variable is the other cash register that we're comparing this cash register to. In our doc test, we'll create one cash register with 2 loonies, that's $2 total, and we'll create a second cash register with 1 toonie, also $2. That means that when we compare them, we hope that the result is true. For the type contract, self and other both refer to cash registers, and this method should produce a Boolean. In particular, this method will return true if and only if self and other have the same total amount of money. In order to decide if two cash registers are equal, we've decided to compare the total amount of money. So, self.getTotal should produce the total amount of money in the current cash register, and we want to know if that number is equal to others' total. Let's go modify the main program to try this out. We'll remove the old code, and then create 3 cash register objects. The first one has 2 loonies, the second one has 1 toonie, and the third one has a loonie and a toonie. Let's print what happens when we compare the first one to the second one, and the third one to the second one. When we run this, we see that the first expression produces true, and the second one produces false. Let's step through this in the debugger so we can see exactly what's going on.
We'll set a breakpoint by clicking in the gray area next to the word class. When we debug, the program runs until it encounters a breakpoint. Each time we click button Step Over, we define another method. We see that we are paused on line 68,
and that we're about to execute if _name equals the string _main. Down in the locals section of the debug control window, we see that variable _name has as its value the string _main, so this condition in the if statement will evaluate to true. Here we confirm that. We're about to create a cash register and assign the memory address of that to variable CR1. We'll create the next 2 cash register objects as well, assigning them to variables CR2 and CR3. We've been clicking button over, which executes the current statement in its entirety all at once, without showing any intermediate steps. We could instead, if we like, click
Step Into,
which steps into any methods or functions that get called. We're going to do that here. Now, if you'll recall, we wrote an _eq method in order to hook into the Python syntax for the == symbol, the comparison for equality. So when I click
Step Into,
we will actually be taken into that method. Here we go.
Here we have an indication of where the program is paused. When we click, we see the call stack. We can click to jump to that location in the code. Notice that the stack data now displays information in this context. Here, we see that variable CR1 refers to a cash register object that at a memory address that ends in 26D8, and that variable CR2 refers to a cash register object that ends in memory address 2828. Switching back to method _eq on the call stack, we can see that variable self refers to a cash register object that ends in memory address 26D8. That's the same object that variable CR1 referred to. Also, variable other refers to a cash register object that ends in memory address 2828, which is the same one that CR2 referred to. We will now step into method getTotal. This is being run in the cash register that CR1 refers to. In the stack data pane, we can examine the contents of that object. Stepping again, the return value is shown. When we click Step Into again, several things happen. Method getTotal exits, returns the value to method _ZQ, and then calls method other.getTotal. We click Step Into, watch how the return value disappears from the stack data, and we have a new memory address, the memory address for the object that CR2 refers to. Here we go. Notice the new memory address, that's the same object that variable CR2 refers to, and the contents confirm this. Stepping again, we see that the total value in this cache register object is also 2. When we step again, method getTotal exits, returning to method _ZQ. The expression in the return statement has been evaluated. Self.getTotal produced 2, and other.getTotal also produced 2, so that the return value for method _ZQ is true. Stepping again exits method _ZQ, returning to the main program. When we click Step Over instead of Step Into, we will execute this print call all at once. We won't pause inside method _EQ. Execution of the program still has not completed. We are still in the debugger. We need to click Step Over one more time to exit the program. We're now going to explore what happens when we don't define our own method _ZQ. We'll select all the code in the method, and then comment it out. Now that we don't define _ZQ ourselves in cache register, that means that when two cache register objects are compared for equality using the double equals operator, we will use the _ZQ method inherited from class object. That version of _ZQ compares memory addresses of the two variables, not the contents of the objects. That means that when we compare CR1 and CR2 now, they will compare as false because CR1 refers to a different cache register object than CR2 refers to.